Hi, so welcome to my talk today. I think you have seen a lot of code, and let's switch a little bit to the architectural stuff. So you'll see less code, but a lot of diagrams in this talk. And let's discuss a little bit atomicity and consistency across database and messaging system. Shortly about me, my name is Andrei, and I work as a part of Tanzu Labs. This was former Pivotal Labs, and my job currently is to support different clients, different customers with kind of modernization projects, so to help to resolve different problems with applications, kind of concurrency, scalability, migration to be cloud native, and so on. I also commit in some open source projects, mainly in Spring and Apache, and sometimes talks on the conferences. Agenda for today, I would like to start to explain the use case, why we need this stuff at all, what happens, what kind of problem we would like to resolve. Then try to solve it just naive way, direct way, and see what happens. After that, we'll go to for the classical outbox pattern and check some variation of that with consent pros. And I have still some time for discussions as well. What is the case we're discussing? So very often in my projects, customer has a kind of service or applications that need to update something in the database, but in the same time would like to send a message in the message broker. And these two operations should be atomic. So either they both are successful or both failed and nothing changes. Just for curiosity, how many of you have such kind of problems in your projects? Just raise your hands. Oh, quite a lot. Thanks. So one more concrete example, I worked some years in the e-commerce domain and have a checkout service. So in the time when cart is already prepared and the customer put all stuff in the cart and press the order, then checkout service need to lock the cart, set the status, and send the message for payment service and fulfillment service to process this order. And in this case, it's quite important that the change in the database and in the queue need to be atomic. How to achieve it? Let's try some direct and naive ways, and let's see what happens. So first of all, I try to put my send a message inside the database transaction. So I update my status first, then send a message, make perhaps some other updates, and close the transaction. Successful case looks good. It works. If the send a message and commit of transaction are successful, no problem at all. Let's say another case. Let's assume that our broker has hiccup and not possible to send a message at time, and send a message fails. In this case, it's also not bad because probably we have an exception thrown from the send a message, and we be able to roll back a transaction. Still, we have consistent state. Yeah, unfortunately, they don't send a message, but at least we don't update the database as well. But what happens if the message will be sent successfully, but the database transaction fails because of some constraints violation, for example? That's could happen. In this case, unfortunately, we have inconsistency. So message was already sent and transaction was rolled back. So we have no changes in the database, but we have a message sent to the other services. Let's turn it a little bit and try to send a message after the transaction. So let's close transaction first and then send a message. Again, in the successful case, it works perfectly. If the transaction fails and we have some constraints, it's also not bad because, again, we have an exception and will not try to send message at all. We have, again, consistent state between the queue and database. But what happens here if the send a message fails? This little bit more difficult problem because we have just an exception somewhere in the handler, And normally we have no enough information to retry the message. Yeah, so it fails, and we kind of lost the track. So this is basically the main problem, that if the event is not durable, if it not persisted, we lost completely the track and we cannot retry it. Exactly to solve this problem, there is a classical outbox pattern. Yeah. So what is the idea of the classical outbox? I just take the picture from the service pattern catalog. The idea is, beside to just update the database in this case, our application save or persist all necessary information to send event in separate table. They have name of outbox table. And there is a special loop, so special thread or process who check this table, and as soon as there are some entities there, some events, just send it into the queue. The question is only how to deploy the service. So there's several ways to do it. We can basically place this together with application in one process and make it a separate thread, or we can deploy it in the different process. What do you prefer? What do you think? What is the pros and cons of that? Any opinion? Yeah, please. Yeah, but there is another reason why it's really a good idea to make it independent. Yeah, they shouldn't be synchronized. So normally you put this process as a kind of scheduling job. So it runs every minute or every half an hour, every hour. But what happens normally, you would like to scale this application horizontally, yeah? And you create several instances of this application. And what happens if you have this process inside? Then the horizontal scaling is not so easy, because you need to decide which instance take the master of this synchronization job, to make kind of master selection algorithm. Therefore, I always recommend, yeah, you're right, I always recommend to deploy it in the separate process for the customers. It's easily true. But in the sense of the microservices, they still could access the same database. We don't need to split the database, because both of them belongs to the same bounded context. Okay, let's analyze step by step how it works. We have our checkout service, and beside changing something in checkout entity, we save all the information necessary to send an event in the outbox table. And our checkout messaging job, schedule it by time, check or look up for the entities, for the event entities, and if it's fine, something, they send a message into the broker and update the status. This is very important, the last step, because it shouldn't be sent another time. Let's check how it works in the diagram. Okay, success case is clear. Application commits the transaction. We find lookup entity without sending status, send the message, update the status. Perfect, works. Let's check another case. Transaction was not committed, it's rolled back, there is no entity at all. So we have a nice thing in the outbox pattern, that these two tables, outbox table and entity table, is in one transaction. That's very important. Yeah, they either commit the both of them or roll back both of them. In this case, both of them will be, oops, sorry, not sure what happens. So just next slide. So in this case, we just roll back both of them, and events will be also not written. Therefore, it's not found as well by our synchronized job. This is a more interesting case. What happens if our send message fails here? So our job tried to fail, just send the message broker is not available, message has failed. Basically, it's not a huge problem, because we run this job periodically. We run every 5 minutes, every half an hour, every hour, and it will send in the next try. We make a next try, we find this event, and we'll send it. There is a little bit even more interesting case. What happens if the message will be successfully sent, but update status is the last operation. Update status in the event table will fail. In this case, the next run of the job will still found this event as not sent with not sent status because our status was not updated. And what happens? We have duplicated message. That means that the outbox pattern still it's still possible to have a duplicate. It's not guaranteed that we have not duplicated message here. Let's see which pros and cons outbox pattern has. The first, of course, is kind of solve our problem with atomicity between the database and queue. Yeah, so we have either changes in the database and message, or we have nothing. Also, there is one nice feature, sometimes it's nice. When we scan the event table and we find more than one event, we can kind of combine small messages in one bunch and send it together. There is a possibility, sometimes it's really helpful. What is the disadvantages of this approach? It's necessary, of course, to support additional job, to maintain it, to write it, to deploy, to monitor. Another disadvantage that I already shown that if messages still can be duplicated. Yeah, so we have not guarantee that it sent as exactly once. So we need to apply additional mechanism to avoid that. Another problem with this pattern that send a message occurs with certain delay. Yeah, so application works, updates the entity, and message will be sent not immediately, will be sent when our synchronized job is working, and depend on our setup and our business use case. It could be a certain delay. Sometimes it's not a problem at all. We have a kind of eventual consistency in this case, which guarantees the consistency, but not immediately. After some time, it will be in consistent state. Another not nice side effect of this approach I have seen, especially if there are a lot of messages, when the application itself tries to send a message, is a kind of distributed for the time. And if you do it in synchronized job, it's possible to have very much messages in short times that could overload another services if they're not designed in the resilient and scalable way. So we have really peaks. So every hour we send 100,000 messages in some cases, and not distributed for the whole time. Therefore, in some projects, I propose a little bit variation of the classical outbox pattern. I name it kind of emergency job. What is the idea of this variation? Basically, the application makes the same job. They update the checkout entity, the business entity, and prepares the event entity in the outbox table. This part is very similar to the outbox. But in this case, application tries to send message itself first. So we just try to send a message after the transaction. After the transaction is closed, we try to send it. And if send a message is successful, we update here the status of the event entity. Then we have still this job. It still should be here scheduled. But in this case, job just check if there are some events in the still unsended status. It happens, of course, normally when the application fails for some reason. The try from application fails. But in this case, our job is only responsible for failed case. So it's really run and send a message really rarely in this case. So let's check how it works. If I have successful run, then our application is responsible to send a message. Message is sent, the status is updated successfully, and our job don't find anything, and we'll just make an empty run. If for some reason transaction is failed by the message, it's also okay, because the message will be not sent, and event also is not created in the single transaction. Then just message, so the job doesn't find any events in the table, and also will do nothing. Let's check more interesting things. Let's assume that our application prepare all entity and event, but by send messages fails. What happens then? Then our job have really a value. So it finds some events with unsent status, send it, and update the status. Nice. It could happen if our broker was offline a bit longer time. Then it could happen that sending message by application is failed. Yeah. But additionally, the job will find the event, send it, but it fails as well, because broker is still offline. It's also in this case is not very critical, because next run of our job will still find the event and send it. So it's okay. It's very similar with the classical outbox pattern. Let's look a bit more complicated cases or more interesting cases. Let's assume that our application sent a message successfully, but set status failed for some reason. The database transaction fails. In this case, unfortunately, our job finds the event without status, and despite of the fact that already sent, we'll send it second time. So it still duplicates of the message is still possible here. And the duplication of message is even possible in success scenario. Let's assume that our application send a message in the queue, and just between the application send a message and set success status, our job check the event entity and find that it's not sent and send it again. So it's duplicated. So even in success case, there is a very small probability perhaps, but it's possible that the message is duplicated. Any idea how to mitigate the last case? Yeah.
I would use another status, like in progress or something like that.
But is it really helps in this case? Because application just don't, it doesn't matter which status you set, application not set it yet. So it's send a message, prepare the transaction to update it, but don't send it. It doesn't matter which status you can have the same status or not, but your job will find that there's an event entity with unset status and will send the message. So any idea how to mitigate the last case, perhaps? Yeah. That's almost. Not a delay. What I did for the job, just check, and if the event is very fresh, if very young, is just created some seconds ago or some milliseconds ago, just skip it. It's also not critical because you can send it on the next run of the job. But if it's really young one, say perhaps application is created, send it but not update the status. Let's skip in this run and say let's check it in the other run. So the last case could be mitigated with certain probability, of course. If the application have a huge delay for some reason between the send event and update status, then we still have the same problem. Yeah, let's check the pros and cons of the our emergency job way. So yeah, it's again like a classical outbox pattern. It's guarantee that the database update and event will be atomic, and the message broker and database will be in the same state. Yeah, in the comparison with the classical outbox pattern, we send most event natively. So in the most of the cases, perhaps this will be even 99.9%, the application will send the event, not the job. Unfortunately, we still need to support this additional job. We need to deploy it, maintain it, monitor it. Also, event could be duplicated, even without transaction failure. I say there is mitigation for that, but in general case, it's could be duplicated if the transaction fails on application. In theory, it could be also duplicated without transaction failure. How to deal with that? Yeah, there are different techniques. If you really so the best way, what I prefer to have idempotency on the receiver side. So basically for receiver, it doesn't matter if you receive message once or it received twice. You just check if the ID is already there, I just ignore the second one. This is the best case. But if your receiver is not under your control and there is big reasons to you cannot really easily achieve idempotency on the listener side. Then there is a techniques, queue-specific techniques. So it depends on which product you use. Either is RabbitMQ, ActiveMQ, or Kafka. There is a possibility to mitigate duplicated messages either in broker or in the producer side. Also, a bit disadvantage that events are sending by two different components. So you need to inject your sender inside the application, and you need to have a sender inside the job. So basically, it's a bit mixed of the separation of concern. In the classical outbox pattern, only the job is responsible to send in application, only responsible to update the database in one transaction. Here, part of the messages could be sent by application, part of the messages is the job. Also not possible to group event. Perhaps sometimes it's even good because we have gradually distributed load. So we have not anymore these peaks because application just sent events after they update the database. And also a big side effect I have for me by one customer that sometimes you need to guarantee the order of event. And this approach could easily break it. So if application fails, then application will continue just so first you set just to send an event, application will continue, and this event will be sent later on with a job that could be completely break the order. So other events that should be sent in the logically before, so after this failed event will be sent before, and the order was easily break with this pattern. But the very good feature of this variation that the load will be distributed gradually. There's not these peaks. Conclusion. The first outbox patterns as this variation with emergency job is solution for the atomicity between the database and queue. It's a good solution. Unfortunately, it's not a free lunch. So we need to do something. We need to implement this scheduled job. We need to support it. We still have some drawbacks and disadvantages. Therefore, I recommend first to check your business case if this consistency is really required. So because imagine I send some statistic events. In this case, if I lost one event or if the database will be in consistent state, it's yeah, it's perhaps not very nice, but it's okay from the business. I can tolerate that. In this case, I just suggest don't to implement outbox at all and just send a message after the transaction close, like in direct way, which we analyze in the beginning. Yeah, that's basically all what I would like. But so if you really need it, so your business requirements in the financial service or in the e-commerce, so you really need this consistency, then outbox pattern really helps. That's basically all from presentation, and we have some 4.5 minutes for the questions, so perhaps 2-3 questions. Please.
What about distributed transaction two-phase commit?
Mm-hmm. Mm-hmm.
A message broker some support transactions?
Yes. Yeah. It's a very good question. So basically, we have even for in GE Word possibility to have a transaction across different sources. So we can use a GMS, so GMS message send, and the database transaction. We can basically make a scope of this transaction, including the database and GMS. It works. The huge disadvantage that it really limited for frameworks, so your framework should support it, distributed transaction. And another disadvantage from best practice is quite complicated. This XA communication, it's really complex. Yeah? And under the load, the good scalable system, I wouldn't recommend to apply that. This is the main problem. So basically, yes, is a way to resolve. Before I even have a slide about that. So thanks to the question. Yeah, so there is that possibility, but currently I don't recommend customer to use distributed transaction if the requirement was scale services and put it in the cloud and something like this. Process a lot of requests and a lot of load. Other questions? Okay, if not, I will be here. Oh, there's one. Huh? You mean mitigation, duplication of the message, yeah?
Out of ordering. So if you have event 1, event 2, event 3, but they're reaching the broker.
Ordering, yeah. Yeah.
Can you have like a suffix that says this is message 1, this is message 18?
So even it's in some brokers where it's supported out of the box. Yes, it's the idea. So every for example, in Kafka you can do it. So every message, message that you send have a timestamp. So even it's not ID, and incremental ID is difficult because if they have number of applications, different instances, how you will manage this incremental ID is difficult. But timestamp could help. Yeah. So if you generate a timestamp, of course the time should be synchronized between the application instances. Then the broker guarantee on the end, even if you send a different order, it will be sorted and delivered to the consumer in the right order. Yes, it's possible approximately in this way. Yeah. Yeah. It's possible, but again, not with some efforts. Either is broker supported, or you can do it basically in your own implementation as well. But if your messaging broker has this embedded feature, why not to use it? Yeah, please. Could you explain a little bit what you mean with listen to yourself? So there you mean send it before and okay, so it's okay. So you mean that it's kind of confirmation in the service itself that message is sent, yeah, and only after that to close the transaction. Okay, but basically it's not a 100% solution. What happens if you don't receive this confirmation from the queue? It could be the case that message is not sent, yeah, but it could be the case that message is sent, but this notification is not coming. So again, you're not sure 100% what happens there. And the second problem with this, I also don't recommend to have database transaction too long. So if you have some remote communication inside the database transaction, it could be problem for application scalability. If the transaction takes quite a long time, it blocks or lock some resources, and if you have concurrent access from different applications, it could be a scalability problem from the database level. Any other questions? Yeah. Sorry, I didn't hear. I didn't hear. It cannot hear. Alternative for outbox pattern. Yeah, there is. I would say there's more or less two alternatives. One alternative is just to ignore them. I say in my business case, I can leave because the transaction failure in the tested system is quite rarely happens, and I should care about perhaps this one, so 0.1% of the cases. And I say I can tolerate it. I have another check process afterwards, and it's just okay if I have inconsistency. This is one approach, and it works for a lot of cases. Second approach, for example, use a distributed transaction or something like this. Yeah, but it has also some cons. You shouldn't do a lot. It shouldn't implement a lot in this case because it's supported by J container or Jakarta. But from other side, it's very complicated and not scale good. These two alternative of the outbox, what I know. Okay, we already out of the time. Is any other questions? No? Okay, so thanks a lot. I will be here till Friday, so you can also pick up me and discuss and ask me any time.